streaming, Ajay,
Okay,
on other device. Yeah.
fine. Let's start now. Okay, good morning, everybody. CQ, CQ, CQ. This is with Uniform 2 Tango Golf Golf. Handle is Ajay, Alpha Juliet, Alpha Yankee. Along with me, I have Devendra. And we are from VU2PHA, which is our club repeater. We operate on VHF frequency 145 decimal 100 megahertz and UHF frequency 437 decimal 000. We have our nets every weekend. The club email ID is vu2pha at gmail.com. Let me repeat that. Victor Uniform 2 Papa Hotel Quebec at the rate gmail.com. And we also have a website which is www.punehams.in. I repeat, www.punehams.in. You can search for us on Facebook by name Pune Hams. Same handle on X, that is Pune Hams, and Instagram, Pune Hams. And you are watching us live on Pune Hams YouTube channel. So that's about us. Now, let me just introduce you to today's guest. When we have Dhiru, our own Dhiru Kholia, who's a very avid home brewer, and he's a next gen or new generation home brewer, is what I'd say. Uh, he uses a lot of microcontrollers in his activities. He also uses AI and a lot of software tools, and that's what we are going to discuss today. So, welcome, Dhiru, to this podcast. Thank you so much for taking out the time, and let's directly dive in. So, first, I'd like to ask you, Dhiru, about your early beginnings. How did you first discover amateur radio, and how you got into this hobby?
Thank you, Ajay. Thank you, Devendra, for having me. Yeah, I am Dhiru Kholia, an amateur radio operator from Pune, India. And as Ajay mentioned, I like homebrewing stuff. But to answer your question, I think it was 2014, 2015. I don't remember the exact sequence of events, but I had a RTL SDR on my desk and I started listening to ADSB traffic and FM stations back in Sweden. I think there was this push, right, from hardware is the new cool thing. You have to get into hardware. One of the ways you can get into hardware like is to experiment with microcontrollers, LEDs, RGB LEDs, and like variable LEDs on your shirt or something. So I think that got me interested early at around that time into amateur radio. And I think then when I came back, that was in Sweden, Stockholm. And when I came back to Pune around 2017, 16, 17, I wanted to get into hardware again, right? Do hardware security again specifically. Then I picked up a TP-Link router and I soldered 3 or 4 pins to it, right? Like the header pins to it. And I thought I have become a great hacker. I felt very accomplished and like I started feeling very proud of myself. Like then I thought I should get into this deeper. And then I quickly searched for like, hey, is there a club near me where I can interact with like-minded people? And that is how I landed the next week or something like that at club and met Srini. The first person I met there, I think, was Srini. And after that, we never looked back, right? And that's how the journey started, I think. Like, yeah.
That's great. Dhiru, do you remember what was your first electronic project? Maybe non-amateur radio related, but what was your first introduction to tinkering or doing some soldering or doing some project in electronics?
Right, right. So I think like the first electronic projects I like in my when I was in village, we didn't have like official electricity, right? So what I dreamed of like connecting switches around like glowing bulbs, turning them on and off just on like in my head, right? Just out of like why I don't know why, but I did that. But when I moved to Firozpur in Punjab, one day the electric bell fell off, right? It was I don't know why it fell off, but it fell off. I picked it up, then I invited all the members of the family quickly, like, and I connected it to a light socket, right? And I turned it on. Then I panicked, of course, because it was quite loud and everyone was very near to the bell. So the mom had to jump in and turn it off, and she was not very amused. I think that was the first electronic project when I was very, very like small, right? A kid. Then after that, I didn't get much time actually to pursue that hobby or any of the electronics or soldering, any of that stuff in my like school days. The other project which I did was electroplating, which I think every kid does. Like you have to find copper sulfate, and that took more than half a day. Google Maps didn't exist. I went on a cycle. I asked around where can I get copper sulfate. People had no idea what that was. I mean, most people, I think, right? And I have forgotten what that is, like what it was exactly. But I found it after half a day in Jodhpur city. Then I connected it. It wasn't working. I expected it to work instantly, right? Like turn it on, it will work. Like, but of course, once it started working after some minutes, it was like very, very like positive and reinforcing, I think, learning. So that was the initial days, but in college, I don't think I picked up any soldering stuff in school days, I think, yeah. And
So Dhiru, we are aware that you have also got good software background, but if you see the normal IT software developers, they usually come from a very specific background, C++, and Python and databases, and usually they start with Windows. But you are into a different type of software. You work on Linux, you work on various IDEs and stuff like that, which obviously you use for programming your microcontrollers. So, what was your introduction to that type of software, and specifically on Linux? How did you get hooked onto Linux?
yeah, I think, like I mentioned before, also, it's always like the information which is around you, right? Like the people you interact with, the environment which you are in. Around that time, like it was school days, around 10th, 11th, 12th. I was already reading some hacking magazines and Reader Digest. Like Reader Digest had this article on how Kevin Mitnick was arrested and like so various reasons, of course. And then I got very hooked to these hacking articles, this kind of mindset, right? And then a lot of people in my school, like they started like exploring Linux in the same time, around the same time, like in this was 11th or 12th grade, I believe. And that is how I got hooked, right? One of the initial challenges was we were using this Turbo C compiler, which is like now it seems silly, but it was one of the best, I think, for its time. And now the project was, hey, I am on Linux now. Linux is booted. How do I run Turbo C Linux on there, right? So that is how I discovered DOSBox, then Wine, and so on. So the hacking already started around the school days, right? Like first it was like how do you run the Windows and DOS software onto your Linux? Then how to get rid of this software entirely and become Linux native Linux user, so to speak, right? So
Right.
it started early on, and that has really helped, right? Like this learning Linux and being productive, not being able to play games, not being able to do any like time wasting activity because everything was hard, nothing played on it. The video acceleration was often missing, so you couldn't watch videos or play games, right? So naturally, you became more productive. That's one of the benefits.
Great. There one specific question, and this is related to more of Linux as well as the coding part of Arduino and various other microcontrollers and a lot of use of stuff like Raspberry Pi. If you see, there are a lot of amateur radio operators in our fraternity who may be very senior people. I mean, age-wise, maybe, and
Right.
those who are sort of a little bit, I would say, awkward when it comes to exposure of Linux. So when you started Linux and the current scenario, so that is on the Linux side, what do you feel for how easy or how difficult it is for somebody to get into Linux as a replacement to maybe whatever OS they may be using earlier, and how similar or different it is, one. And similarly, second, I would like to ask that somebody with no software background, I mean, absolutely no background, if somebody wants to get into maybe writing small programs for Arduino and ESP32 sort of things, how difficult it would be for somebody to get into this part of the hobby?
Right. I'll answer the first question first. So Linux used to be tough. It maybe developed a reputation for being tough, but that's no longer true. It hasn't been true for a long time now. It's very easy now. Like if I remember, like let's say you buy new hardware and you insert the Windows CD or pen drive, whatever these days is there, right? It's hard to install Windows because then you have to, even on the installation phase, you have to look if your, let's say your hard drive is special, new, or some controller is new, it will ask you for drivers, right? And all of that. With Linux, everything, most of the drivers are inbuilt these days. Even the Wi-Fi works out of the box, the graphics works out of the box. Like Ubuntu even has integrated NVIDIA drivers, it seems, and like latest ZFS, and like they have gone even ahead like of others. So it's very, very easy to get started with Linux. Of course, same Chrome works, same Firefox works, same web, whatever, WhatsApp work, web, Telegram works. So you wouldn't feel a difference in day-to-day activities, right? Of course, let's say you are using some native Windows software for PCB development, for example, it will be, then you'll have to make, again, first you'll do the same which I did, right? First you make that software work under Wine, which is Wine, and then you will then learn natively KiCad or something, right? So it will be a journey for sure, but the journey is much easier these days, I believe, much easier. And the second question is, I think age is just a trade-off, right? Which we can't avoid. uh, you get something, you lose some skills over time, right? Or something, it's a trade-off, I think, in many ways. So we shouldn't feel that age is the limiting factor. It's just curiosity. And when I started, I remember the first day with Arduino, I felt very proud, right? I wrote a button, I wrote a program. When you press a button, the LED will grow, right? I felt very accomplished. My brother was visiting me around that time, and I showed it to him, like see this genius work, right? Like I felt very like it. So, but I think that positive kick, once you do something even small, is very essential to carry you through the journey, right? The journey is very long; it's never ending, right? The process of learning. But if you get a large kick at the start, just by copy pasting some examples from the internet, studying them, how they work, deviant. So that kick is very essential. And I think that kick works at any age, right? Irrespective of age. So these days, the resources, YouTube is there. Of course, Chat GPT is there. You can always ask Chat GPT, right? Hey, I'm new to programming. I don't even know what programming is. Can you like quickly help me out? Like with, I want to like glow this LED on Arduino. I have this board and this, and ChatGPT will give you like sequence of steps, and you can even ask them like, don't reveal everything, don't reveal the answer. I want it to be sequential. So you can customize the learning for you, right? It's quite brilliant these days. This AI thing, yeah.
So, Dhiru, one question I'd like to ask you is, when we think about somebody who's like a home brewer, avid home brewer, or somebody who's always been tinkering, maybe somebody like our Elmer, VU2ASH,
Yeah,
Kaka.
Tata.
What comes to mind is, somebody who's working on resistors and capacitors and so many discrete components, or maybe a few of them actually working with the tubes and some old stuff. And you are completely opposite. So you are usually starting with some chips, and then you are building a circuit around that without so many of discrete components. So what's your take on home brewing? I mean, how difficult, how easy it is, or I mean, what does home brewing mean to you from a hardware or component point of view?
Right. Analog has always been an hard thing and an art for sure. And I was reading somewhere like some of the new USB standard or some standard, some communication standard, how it uses analog amplifiers or some kind of like analog differentiation to recover the signals and everything, right? So it's all, when you look deeper, it's all analog always. Digital is an abstraction for sure, right? So of course, I mean, it's also we have to move according to the time, right? Like earlier, we didn't have these fancy microcontrollers and like Arduino IDEs and this high level of abstraction. So we had to do what we had, right, with that stuff. But now, since we have access to the latest stuff, the latest technologies, the life becomes much simpler in some sense, right? Let's say you wanted to create a CW beacon, right? Earlier, I can't even imagine. Of course, Kaka will have to come on the talk, give a talk about that, like create a basic some kind of oscillator, a controllable on-off oscillator or something using analog components and all of that. Now it's much simpler, right? You have your microcontroller, pick whichever microcontroller you like, connect it to SI5351, and then simply do an on-off, right? Like you blink an LED, you do that, right? Of course, with delays and whatnot. And that's the end of the project, right? It's like maybe like half an hour project for anyone like who knows basic stuff, right? Like even if you don't know the basic stuff, you can ask Chat GPT, copy examples from the repository and whatnot, right? So I think it's an artifact of time itself, right? This shift in mentality, it's just a product of time.
So, so you've been doing a lot of, so I've been seeing that you have been doing a lot of multiple projects. I saw you were building class A, B, C, D, Z type of amplifiers. You were working on WSPR beacons, Meshtastic, APRS, transceivers. So I also, I think you were toying with the idea of having a all digital transceiver and then modifying it for CW and SSB. So
Right.
amongst all these ham radio related projects, which of the ones has been the most satisfying projects for you, and why?
I think let's turn on the camera. Maybe I try to turn on the camera.
Sure.
Let's see if we can see it. right? You can see this, right?
Yeah, it's
So
visible.
I'll quickly remove some stuff and quickly put on some stuff in there. So I think one of the first project which I, of course, like we talked about the CW thing, right? CW beacon. So this is like, this is the heart. This generates a signal, right? This thing. You have the microcontroller in here. Then you have the SI5351 PLL, essentially a signal generator, a clock generator here. And then you have this for timing, right? An RTC module for timing. Once you have this, the power is like, let's say 10 milliwatts, right? Which might not travel too much, especially when you are on a poor antenna, limited antennas. This thing has started. Let me quickly fix
It's okay.
this.
It's still visible. So yeah, it will
It's still visible.
stabilize. That's okay.
Let's stabilize this. Yeah, it's the power line frequency compensation thing, right? It's a mismatch. And then you connect it to this 5 watts amplifier, right? 5 watts or 10 watts, whatever you prefer. So yeah, this has been very satisfying, right? Working on signal like small signal generators, essentially very simple generators, and then power amplifiers like beacons, essentially, right? It could be CW beacon, it could be whisper beacon. This can do FT8, FT4, whatever you want. Essentially, digital FSK modes, right? This has been very, very like I think satisfying to work on. Yeah. Let me see if I can turn this off. Yeah.
Okay, thanks, Dhiru. Just a quick comment. I hope your entire setup is as clean as the one which you are showing. And
It's not. It's not. It's definitely not. That's why you see a limited view of the room and not the background. Yeah.
Okay, that's great. Dhiru, just take us through a workflow. So from your idea to creating a schematic to actually creating a PCB or getting the SMD things done. How do you go about any idea?
Most of the time, the ideas doesn't have to come through me. It could be some like a club member, Joshi sir, Kaka, Srini, like it could be anyone, right? And then Paresh sometimes, and or Brad, my like friend in US. So the idea comes from there, like, hey, we want a beacon. Let's say the idea is we want a beacon, CW beacon working for us 24/7 on different bands, right? Or maybe one band, for example. So the initial process starts in the head, like what is needed, right? Let's say we need a circuit for sure. So what components are on there? We have to think in terms of modules, right? Like one, we have a signal, then we need to control the signal somehow. So the MCU naturally comes. Which MCU? Does it need GPS? Does it need timing? Does it need what does it need, right? Wi-Fi. So accordingly, you select MCU. So it has to first, the whole picture has to fit in the head. It has to start working in the head itself, right? And then once you have a slide like a better picture, then you actual layout, do this layout, schematic layout, right? You do in KiCad, and then you do the schematic layout, then you do the PCB, you do the schematic, then you do the PCB layout. Then the interesting part comes, right? These days you have a choice. You can get the PCB manufactured from Robu or JLC PCB, whatever, but you also have the option to get the PCB assembled for you from JLC PCB, right? And that saves a lot of time. Let's say the circuit is small, it can be assembled in, let's say, for example, the beacon can be assembled in 30 minutes, not a problem. Let's say you have a complex transceiver, like we'll come to that. DDX transceiver is a bit complex. So we might opt for JLC PCB assembly, right? So that's another workflow. And once the PCBs come, then you have to do the whole boot up process is there, the bootstrapping process there. We test the circuit and everything. So it's a relatively simple process, but but the most important part that it has to first work in your mind, right? How the whole flow, the RF flow has to feel right, right? And sometimes, I mean, the process doesn't work, of course, always. Like some of the circuits failed. Like in one of the initial versions of DDX, the oscillator used to, because when you transmitted, the heat was being generated, it was being dumped onto the PCB, and that kind of drifted the oscillator, right? But of course, this happened because you forgot to do a heat thermal simulation, right? Then I learned about the thermal simulation process using ADS. I have written an article on that. So slowly and slowly you pick up skills, right? You want, even after things work in your head, sometimes of course, the real world will throw surprises at you, right? Curveballs at you. So it's not always a simple process. Yeah, for sure.
Dhiru, do you use any simulation tools before you actually go in for getting a PCB done?
Yes, I use LT Spice. These days, I have also started using ADS. There is this ADS industry standard, which for thermal simulation only, right? There is no open source equivalent of it. So I'm forced to use ADS for thermal simulation. Essentially, you import a PCB onto it, And then you can define the heat sources on it, right? Like, hey, this is the regulator, this will generate 2 watts of RF heat output, and you can define the heat sources, and then you can see over time how the heat expands through your board, right? Like the PCB. So it's very cool. It works very seamlessly, and it's very expensive. But yeah, I mean, I simulation is critical, and especially LT spice. If you are, let's say, prone to making silly errors, right? Like many of us when we started out, like everything is it's not connected or like silly errors, right? TCAD will help you, but only so much, right? If the whole concept is wrong, then LT spice will catch wrong concepts, not just wrong connections. It will catch wrong concepts, like, hey, this doesn't work. Like this is totally like BS, right? So it's really helps, I think, to get simulations working.
That brings us to the next question. Obviously, what are your favorite tools, software and hardware platforms? What is that you rely most? I mean, from a tool point of view, or even from a platform point of view, the Raspberry Pi, the Arduino, ESP32. So, what is your what is that you are comfortable with, including the tools?
Right. We'll start from the bottom up. Linux and macOS are fine. Like both are productive platforms, and they don't crash or like hang or have the virus problem or something like that, like a malware problem in journal. Of course, if you are being silly, then they will get affected. But in general, they don't have that problem that widespread. Then on top, you have the application stack, of course, and where all these tools comes in, right? Like KiCad is there, Arduino IDE is there. But a lot of the times I find when you're working with AI agents these days, like Claude, Codex, you work in the terminal, right? And where I'm comfortable with in. So I use editors like Vim, other softwares. What are the other softwares? Like KiCad is there, ADS is there, LT Spice is there. And of course, for what you call filters, there are different software like the marking microwave website is there where you can create your own kind of design your own filters, right? Like LPFs, HPFs, BPFs, whatnot. So a lot of different softwares are involved. And I think Bharat, there is a person, Bharat, friend, and I have written a small like budget RF lab kind of a GitHub repository. I'll share the links with you after the on the call or after the call. So that gives you a slightly better idea of what to kind of what tool set is required and in terms of the softwares. Yeah. Yeah.
Okay. Yeah, we discussed about the heat part. You mentioned about how you go about doing that. But in designing transceivers and specifically on UHF, VHF, I'm sure there would be a lot of issues related to RF or spurious RF and a lot of troubleshooting around that. So how do you go about figuring out the RF related issues or the spurious harmonics that are there on the first is how do you detect them? That's the major challenge. And then how do you overcome that?
Yeah, I'm not very good at debugging at such RF stuff. And I haven't worked at VHF and UHF so far, right? Of course, I use commercial equipment there, like Baofeng, whatnot. But I haven't designed my own VHF, UHF stuff. So my experience there is not like there yet. But HF, I can say that, yeah, like let's say you have an amplifier, and of course, whenever you are like debugging a circuit, let's say an RF amplifier, for example, you always have your digital power supply connected to it, and you can monitor the behavior, right? Like how is it consuming power? What's the expected power input? What's the variation in the expected power? Like let's say suddenly it goes into a like a hard oscillation or something like that. You'll see that suddenly the DC power jump up a lot and all of that. So from the even from the input analysis, you can do a lot, right? Then of course there is the output analysis part, like input you are monitoring the voltages, but the power consumption and all of that, current consumption. And on the output side, you can have a spectrum analyzer or your favorite tool, oscilloscope, whatever, and then you can see like a spectrum analyzer. I'll use that and see that like one time one of the transceivers I was working on, the output stage had failed, right? Like in a sense that it was oscillating and it was creating a hash or weird problem, right? Like it was generating all the frequencies, like it was amplifying like widely, right? Not a single it there was a single tone. It was supposed to amplify only a single frequency, right? The it should be like this, like a clean sharp like upwards trend, right? And it was like a full spectrum noise. That is, of course, that design didn't work for some reason. I still couldn't figure out why. But anyways, like maybe some feedback problem, whatever. So yeah, debugging is hard. And the best part is the best way to debug is to prepare in advance, right? You leave the probe points, the test points on your PCB. Don't take them out. Keep them there. Let's say the oscillator is not oscillating. If you have a probe point, it's very easy. Just touch there, touch the ground, like the corners, wherever your ground thing is, and you will see that it's not. it's not giving you a square wave or a sine wave, whatever. So it's very, very easy to like debug when you have proper test points and labeled test points. I'm not always doing this, but I should be doing this. Yeah, more.
Okay. Now, Dhiru, recently we've seen a lot of these IoT devices coming in the market, especially the Titigo, Liligo type of
Right.
things, and the Pimorani type of devices. So, how does it impact typically the APRS trackers or the Meshtastic stuff, and how does it expand the possibility of utilizing these cheap, low cost, low power devices in our hobby?
Yeah, I think they're brilliant, these devices, because first of all, they reduce the entry cost, or what you call the barrier in entry of like barrier entry point, right? Like the cost of entry. So they're cheap. That's the first thing, comparatively cheaper than commercial equipment, right? Let's say, and sometimes even on, let's say, if you are operating, let's say for in like take a concrete example, if you're operating LoRa, right, in the 868 or in the 433 band, you get a lot of allowance in terms of power, and LoRa is very, very sensitive and like, so it gives, again, it's about that initial kick, right? Even let's say you don't have an amateur radio license, you can still do LoRa stuff on 868 bands and like these open bands, right? And that will give you the initial kick, right? Like what happened was my friend does not have a license, so he climbed onto this Ferguson Tekdi, and I'm in Undri Chowk, and I'm in like a bungalow, and the bungalow is surrounded by tall buildings. So initially, when he was transmitting, like I couldn't like receive him, and when I was transmitting, of course, there was no chance of him receiving me. But then I connected my this super gain antenna like on the balcony, and then he started climbing the Tekdi upwards, right? And then at some point we were able to communicate, like the LED started blinking, right? So that it's receiving, and his LED blinking started blinking there. So then he was like, oh, this works, right? This works. So it's that initial kick and excitement, right? So these devices, let's say for like 2,000 rupees, 3,000 rupees, they give you this very like initial kick, right? And even without a license, so to speak. So I think that part is very important, where that initial push or impetus will kind of carry you forward through your journey, I think. So
Great.
very important, and like especially also these devices like can be connected to sensors, right? You can build a sensor network. You can build essentially the possibilities are endless. Whatever you can think, these like you can do it, I think, with these devices.
So, you've been publishing a lot of your work under this open source license on your website. Can you share something more about your website? And equally interesting is how you're hosting your website. So that's one part. And also, what is your opinion? What in your opinion, what is the role of open source software in our hobby?
Sure, let me quickly search. I can only move this bar down. Yeah, there we go. This is the rfcorner.in website. It's essentially a notebook, a blog of sorts, and it's open, right? It's like the source code is published on GitHub. So what I did was I bought a domain. This in domain is there using Big Rock registrar, and then GitHub, and the website is hosted on GitHub pages, right? This is the website. I mean, the source code resides here. It builds the pages. It's a Hugo blog. Like a Hugo is a static kind of website generator or something like that. So essentially, it publishes to GitHub pages internally, and it uses this. Essentially, it does a CNAME or something like that. So you see everything on rfcorner.in, right? And let's have a quick example. Take a quick example of what is in there. Like recently, I worked on this half-wave HFDX vertical DX antenna. Then this thing shows LPF filters. So you'll see variety of articles on here, and this open source documentation is very, very important to me, and the open source projects have been very important to me in my own journey, right? This is how I learned stuff, and this is my way of contributing back to the community, right? By publishing this stuff here. And many times you'll see that these articles have links to my GitHub, where you can learn more or get the PCB boards for free. Like the designs, the entire design, most of the times are free. And yeah, did I miss like some part of the question, Ajay?
No, I think you covered it. You were also hosting your web server on a solar powered
That's right.
device. Yeah, so can you share some more information about that?
Yeah, let's take a look. Tags. Earlier, what happened was that, let's have a look here. Yeah, this same website was on Solar for many months, like around 3 or 4 months. But then I moved from that home, and that is how I lost that setup, right? And it was inspired by this article at this website, which still runs on Solar, like low tech something, low tech magazine or something. So when I was inspired by this, I created my own, and this is how I did it. So this was the case for the where the everything was hosted. This was the controller, charge controller, and then this was UPS was connected to the my Raspberry Pi Zero or something like that, right? 02W or something like that. So the full tech stack is in here, like it's described how to do it, and there is only one right way to connect it, right? So you cannot mess it up. So it's very easy. You have the solar panel charging the lead acid battery. I tried using lithium ion, but was not very successful. And I think the technology is much better now. So it's a simple project that way, and it was reliable for many months. But then I found that, of course, after marriage and all that, things change and a lot of things are different now. So now the life is much simpler just by hosting it on GitHub pages, right? Like, yeah. But yeah, especially if you're interested, we can start doing this again. Like, why not, right? Yeah.
Right. I recall we had all purchased this Antuino SWR bridge, which was created in
Right.
Lamakan, and then you had modified the software. I think you had also added some GUI to that tool. So what prompted you to get into tinkering that software for that tool, and how do you view it now? Is it how useful that tool was or is to all the amateur radio operators?
Yeah, first of all, thanks to Farhan for making like a lot of things open source, like most of the things open source. And Antino was one of them, like the projects. And like when I started Antino, like I noticed some weird behavior, like it was functional, right? Right off the box, it was very usable tool, but there was some few usability and some correctness issues, like one line or two lines of code, like of correctness issues. So I fixed those, and then like I needed an opportunity to hack, right? I was looking for an opportunity, and I saw this as an opportunity for to better my skills and to contribute back, right? And then there is I think this website I found it again today, like the GitHub repository, and you have this. It seems I created some Python, like a small Python script which kind of does a sweep, right? I added the sweep functionality to Antino. It already had some, but I think I changed the resolution, the step size or something, and then I created this graph, right? And this graph, I think, I don't remember now, it's showing some VHF frequencies. Yeah. And I also took it to Amog's home, and he had a nice big antenna, and it was resonant at multiple points. And so antenna, using antenna, we could see that the antenna had like moved slightly rightwards or leftwards, but still it was like fairly tuned well, I think. Yeah. So it was very useful to see the whole how the whole antenna like across the spectrum is working. So antenna that way proved to be a very useful tool. I don't remember if Nano VNA was around that time, but probably not, right? Yeah, it wasn't there at that exact time on, like,
Yeah,
yeah, I
it came
think
later, I
it
think.
came later. Okay, yeah.
Yeah, yeah. But
So
I think the tool itself was very cheap and great tool for all the hobbies. The cost point price point was really it was a real value for money. I mean, yeah,
yeah, true.
the Nano gives you a Smith chart and all. I don't know, or I'm confident 99% people don't understand that. But I think that was a very simple tool, and you really got a great front end developed so that it became much more easier to use it.
Much more easier, yeah. So I think it was a very good addition at that time, and it was very useful. And there is some comparison with GK antenna analyzer, but also it was very available, right? Like anyone could afford it. Like most of the like students also, like if they had if they saved enough and not spend on iPhones, they could afford it and all of that. And it was very like available also. Like, yeah.
Cool. Dhiru, what would you suggest new engineers or budding engineers? What would be the few projects that you would suggest them to get into so that they'll be able to understand more about how things work and really be successful or get some learnings out of these projects that they may be doing?
Yeah, like one of the things which I always try to do is explore first in breadth, right? And then go in depth, right? So cover a variety of topics. Like take a typical, like, let's say in engineering, they teach you like, I have been through that courses. So they teach you like basics of amplifier, two-stage amplifiers, filters, right? Whatnot, right? Oscillators, how to build your own and all of that. So you can explore all of that in breadth. And then whenever, if you find a particular topic, let's say I found power amplifiers very fascinating. So I've been working on that since, right? Like, it hasn't stopped, right? That process. So I think that's one idea, like that's one advice, like explore in breadth. And then some of the simpler projects that concrete projects which they could do is like, of course, I learned very late. It's not that I jumped onto this project like for the first time. So this antenna has been great, right? It does not require toroids, just three pieces of wire, quarter wave vertical antenna. So they can build this. If they don't want, if they don't have the space, they can just build a random wire, right? Like I started with a random wire antenna, right? And then they can pick, do, if even if they don't have a space for random wire antenna, they can do even simpler active, not simpler, but different active antenna, right? Like you only have like a window, right? Let's say you only have a window which has some opening. So you just put an active antenna there and you can start receiving, right? So if you're interested in reception, this is one way to go. Like encourage people to like listen to SSB nets, digital radio, like FT8 frequencies, whisper frequencies, whatnot, right? That's essentially the whole idea there, is to give you initial kick, right? Initial success in a minimal way. If you're interested in transmission, then what I have done is I have created like these projects, right? Like, let's have a look like this. Of course, you don't need the PCB. You can just hook using jumper wires and this thing right here. And this will give you a small 10 milliwatt signal. Then you can again connect it to an amplifier. Let's say this amplifier right here. Where is it? It's gone somewhere. Yeah, this amplifier. Again, it can be like, I recommend doing a PCB for this. It can be assembled using JLC PC, or if you are very creative with your like have good skills with soldering and everything, you can do it on like a copper clad board or a zero PCB and things like that. And you can have 5 watts output and get on air, right? Put a filter ahead of it and get on air, right? So these are some of the projects, concrete projects, which you can start like doing, or think, at least thinking about, even if they are not like immediately feasible for you. Yeah.
So Dhiru, on the hardware side, in case somebody wants to get into this, at least who are starting, I'm sure those some of us have got too much of junk we have built over the years. But somebody who wants to start their journey into home brewing and all these activities, what is the minimum or what are the basic tools or gadgets or test equipment that somebody should invest in so that they'll be able to start off? I mean, eventually, obviously, they may go in for some other stuff, but what is the bare minimum that somebody should have?
Right. So this is the exact question like many of us had, and many of like the coming generation has, I think. So Bharat and I worked on this repository, this project, Budget RF Lab, right? Like soldering iron, we have some recommendations. Then multimeter, right? Like a good one. Again, I mean, good one doesn't have to cost much, right? Like, let's say this is Unity UT33D plus is 800 rupees, right? It's it's yeah, 8 times more expensive than the yellow multimeters you get, but it's still cheaper than a much cheaper than a Fluke, right? But it's the right balance, we feel, that between like a good tool and a not so good tool. Then you have the power supplies. Of course, you need a power supply. This is the most critical part. Like, of course, Kaka told us, like when we started out, Kaka told us focus on this, and of course he's right always. So why? Because it allows you to see the behavior of a circuit, right, immediately in a visual way, and that's very important, right? Especially with that display, with a DC-DC converter, the display, how much power is being consumed. Then you have, again, capacitance meter you can ignore. Oscilloscope, again, it's not needed, I think. Why? I'll tell you, right? Let's say you are building a CW beacon, you just need to do one thing, right? What is the output frequency of the thing? Let's say you want to transmit on 20 meter, the center or whatever the starting part of it, right? Band. So you just need to do a small frequency counter. You don't need a full-blown oscilloscope for that. So you can create your own frequency counter using like a Pico 2 or Pico, right? Like a small one. We show you how. We'll show, like, there are projects out there, and my own project is out there. So some of the tools can be avoided. Nano VNA, again, like some people love it, but when I tell about it to my Elmers, they say that in our time we didn't have a nano VNA and we got an air just fine, right? And they're right. So even when you're starting out, even you can avoid a nano VNA for a long time, right? Just cut up the wire according to like measurements and it should work. And it works because my antenna upstairs, when I measure it using nano VNA, like it's a quarter wave and it's tuned to, it has a VSWR of 2 and it gets to US just fine on both sides. So I mean, it's not perfect. It's probably bad, but it works, right? So when you're starting out, anything that works is fine. You don't need to invest on the first day on all the tools, right? Like tiny SA is not definitely not needed. RF power meter again, like you can have it, but again, it's like investment like diamond is a bit expensive. So it's again like depends. Like hot air station, you definitely don't need it. I don't use it much often these days. Uh, SDR, you definitely I will again. It's of course to get hooked. I got hooked using RTL SDR, so it's necessary. But let's say you want a simple transmitter in next 2 hours or something. Again, it might not be necessary if you just measure the initial 10 watts milli output using your like Pico 2 or something like that. It probably you just fudge around a bit and it will get you on the band, right? And of course, there are web SDR where you can monitor your own signals, right? So you don't need to physically own the SDR yourself in the initial phases. Let's say you have a budget of, let's say, 3,000 rupees. Of course, you can't afford RTL SDR then. But in 3,000, you can build a good quality like transmitter beacon or something like that, much at a much lower price than that. So of course, you have what I'm trying to say is that you have to use your judgment, ask around, consider your needs, and buy accordingly. Of course, if you are rich, then you don't need to listen to me. You can do whatever you want. And yeah, some of the other stuff like line tester is there, soldering wire, why the 60-40 mix, LCR meter. Again, LCR meter, I avoided LCR meter for a long, long time, right? I didn't need one until I needed one. My filters were failing. I couldn't tell why my filters were not like behaving well, the LPF filters, the band pass filters. But this tool was extremely useful, right? Like it will show you in nanohenries, the inductors and all of that. And it really helps, right? Correct measurements will give you correct results essentially. But initially, for a long time, it was not necessary for me to get it. So long answer, yeah, but that's it.
Dhiru, would you be able to suggest any websites or blogs, any books on electronics RF for specifically which are focused towards the hobby of amateur radio?
Sure, I think this book is great. Like Chris Bovick, RF Circuit Design. It's very readable. It's pleasant to read, and it doesn't trouble you too much with mathematics and all of that. So I think for me, which are like a bit math hours these days, this book it really helps. Like yeah, and of course there are on YouTube. If you are the kind of person who likes watching videos, then there is a lot of good stuff on YouTube by RF Man is there. Then there is this person. Let me like. Uh, yeah, I'm forgetting his name. Uh, this channel, right? W2AEW, right? There are you will find tons of stuff. Like let's say you are interested in a particular like subject or something, you will find tons of stuff on YouTube. The problem with me is that I don't like watching videos. I don't have the patience, the time, and the energy. So I have to go back to like the old ways of reading or just looking at the schematics directly and then figuring it out, right? Because videos can take a while, like learn to watch and learn from them. Yeah. And so
Are
there
there
are
any
plenty of resources. Yeah.
Are there any communities or forums specifically, Dhiru, which you would recommend people to follow, which would give any, let's say, wealth of information or troubleshooting tips, etc.?
I recommend joining like Telegram, and there is on Telegram we have the Ham Brewers group, right? Ham Brewers. Let me
Okay.
quickly see if I can locate it. Where is it? Yeah, Ham Brewers group. So essentially, if you have a problem or if you want to post like a question or get general feedback or anything of that RF related to RF radios, transceiver, whatnot, Ham Brewing, I think this is the place to be. And this will really help you get like real interaction, live interaction, right? Almost live interaction with different like similar set of like-minded people, I think. Yeah, this
Do
is
you
one
know of any
forum.
courses, Dhiru, which you would recommend, or would you recommend rather than making your hands dirty and going ahead and trying something?
There are a lot of courses. I want to do those courses, but I never find to do those courses, right? There are these courses on ADS, like 64 videos on ADS, how to use ADS. Then there are courses on LT Spice. like how to, that will take months and months to finish and days to finish, then practice and get, like, I simply don't have the time, right? Just a hobbyist, right? I'm not an RF engineer or anything like that. So it depends on who you are, what you want to achieve and like do and all of that, right? But the resources are endless. The courses are endless out there, I think. Yeah. I mostly learn by like this circuit was very, very impressive, right? And the work around it and the community around it, that USDX 1.02 by BARP, WB2 CBA. Like that UDX, like Guido worked on it. Of course, it came from a modification of Hans Summer circuit. So that was really, really useful, right? So I looked at it, couldn't understand it first, then looked at it again and again and again, and slowly started understanding it like that by breaking into pieces, right? That is how I learned. So to speak, like in your like words, getting your hands dirty directly is my approach, right? Instead of the more structured and more uh, proper or linear approach, right? Like learning. Yeah.
There are some of the projects on your website, and what you shared with us some time back. They're really very professionally looking PCBs and all. But maybe it could be overwhelming for somebody. But in case if somebody wanted to try some circuits from your website, RF Corner, which are the projects that you would recommend, and how would somebody go about, for example, starting a project?
Yeah. Let me try sharing the, like, let's say you want to build a, let's say again, my favorite example is beacons, right? You don't need a PCB, right? Like, let's take this thing. Uh, This is the microcontroller on the left side. Then you have the, on here, you have the RTC clock. Of course, that is also not needed. Then you have the SI5351 for generating a frequency, like frequency or tone or whatever you call it. So uh, you just need these two things, right? The MCU, and because MCU is Wi-Fi enabled, this is ESP8266. And so you don't need the PCB actually. You have to, whenever you see a circuit or something, you need to break it down into components, then figure out what do I actually need, right? From here. You don't, a lot of people ask me, is homebrewing about like replicating things, like building circuits? I say it's also about understanding them and customizing them according to your needs, right? That's most important, I think, and advancing them whenever ready, and simplifying them and advancing them both at the same time or at different times according to your own needs, right? So you just connect some jumper wires from here to the SI3 5351. Yeah. Whatever that number is, I always mess that up. So yeah, that's it. So essentially this thing will connect to the Wi-Fi, grab the time from there, control this module, and at the right hand side, like this SMA ports are there, right? Connectors are there. You will get 10 milliwatts there. Then you connect this to, let me quickly show you, that's it's here. You connect it to the this port, the left hand side port of it, and you get 5 watts or whatever, 10 watts at the right hand side, right? And again, this is a PCB, but if you look at the components, what do you actually need? There are a lot of, if you see the repository, there are a lot of versions of it, right? And some of them are not even SMD based. Some of them are like, this is SMD like FET here, but many of them are like through hole also, right? Like you could just use IRF 510, for example. And this component is very hard to solder. This driver, the gate driver you see here, again, you don't need that. There are simpler gate drivers out there, right? They work very brilliantly on 20 meters band, on 40-meter band, and things like that. So you could simplify things according to your needs, customize it according to your needs, and you don't need actually these fancy PCBs or things like that at times, right? So it's easy to get started. You just have to, like, instead of taking it as it is, you have to customize it. Think why is it being done this way? What I could tweak, what are the core components, what I can remove, what I can simplify, and then do it right. Yeah. It's all about, I
Then what are
think,
some
yeah.
of the new technologies that excite you a lot, and how do you see digital things over analog in the radio world evolving in India or even globally?
I am not very good with trends. I think I'm still stuck with the same old Whisper FT8 of, let's call it the older generation or the dialect, let's say whatever, right? So in some sense, I am ahead like with times, but in many ways I'm not. But there are a lot of these projects out there which which do digital voice, right? And I wonder if you could do digital voice with a simpler, these FSK modems, right? Like essentially a single frequency moving around kind of these modems instead of OFDM or complex modems, right? Why? Because this same circuit, the circuits we are seeing right now on the screen, these can do simple FSK kind of thing, right? If these could be made to do digital voice, that would be brilliant, right? So some digital voices, I think, is quite innovative in many ways. And of course, the polar modulation, right? Why are we forgetting that? Let's have a look at polar modulation. So essentially, the idea is you have the traditional like ways of creating SSB. Then you have this different way of creating SSB, and like a more efficient, possibly more efficient. Let me quickly look. Yeah, okay. Google knows about it. So yeah, I think this is very exciting. If a digital transceiver could do like SSB, right, like in a very simplified circuit without having all the linear what you call stages of a power amplifier and things like that and all of that. So this will be very interesting. The POC already works. Of course, it doesn't have many of the required parts like the drain modulation, the critical part, and all of that. But it mostly works. It's you can see a demo on the RF corner also or something like that. You could listen to samples, right? And these samples are a bit scratchy because they are captured over the air. They are not inline, right? Like I actually captured using a SDR kept in a like a, at a slightly like at a slight distance. So they're scratchy, but they're still audible, right? Hearable or understandable that way. So this is exciting for me. I think this is what I want to work on next, if time permits. Yeah.
Great. Dhru, we've been talking about individuals getting into the hobby and all, but in amateur radio fraternity, we have so many clubs. What would be your advice to clubs in terms of getting more people into this home brewing activity or supporting people who like to tinker around or build stuff on their own?
Yeah, like there's my friend OS2 FTG, right? Like ISMO. And one of the things is their clubs are very, very well stocked. I don't know if it is possible because that takes a lot of money and background, like of kind of background wealth or whatever that may be. So essentially having well-stocked clubs, running these clubs, like my friends like Siddesh, like they tried running their own maker spaces, right? There are some like parallel organization, parallel clubs, maker spaces where you have 3D printers, a lot of like hardware stuff where you can tinker around and all of that, right? So we could create maker spaces, hacker spaces, RF labs or whatever, RF laboratories or whatever, but that takes some resources and like a lot of resources to create, I think, and a lot of resources to, and it's harder to maintain them and keep them running, right, and keep them functional. So it's a challenge for sure. But even having like a basic antenna at the club station, getting we do this already in our club, having an active antenna, getting more people to get on air, getting them the kick, right, the initial success kick or whatever the impetus, that's very important. And of course, like a lot of people I have seen from the club, I benefited a lot, right, like tons. A lot of people I see like similar in a similar like thing. A lot of people have benefited from being part of our club, right? And so it's we could do more. We could everyone can always do more, but we are doing, I think, well. I think that way. Yeah.
Quick question, Dhiru. What is the next electronic toy that you are itching to buy?
It's a dangerous slippery slope in some sense, right? Why? I'll tell you the reason. I was thinking about this earlier this morning. Let's say you buy the latest transceiver, right? Whatever the budget affords, you can buy anything if the money allows, the budget allows, wife allows, whatever. But it kills the motivation, right? You also have to think that on the flip side, let's say you buy the latest FTDX or whatever, right? Yesu, Icon, whatever. Why will you have the motivation to create a simple beacon, right? Like a CW 2 watts beacon, or even like not even 2 watts. 2 watts is too much. Like why do you have a 10 milliwatt beacon? What's the fun in that? So in some sense, like it's a question of also everything has a flip side, right? In some sense. So I'm not this I did not understand this point myself, but it was brought to me by my attention by my friend Rafael, and he was like, if you buy that, why will you? It kills your hunger, right? And it's not good for the hobby in some sense. It's not good for the learning purposes, right? So I am not itching to buy anything. If I have to buy anything, it will be a tool, right? It won't be a ready-made product. It will be a tool, maybe a spectrum analyzer or the Rigol some Rigol scope, right? Like a 350 megahertz, because some of the experiments I'm doing these days, they are not 100 megahertz is no longer enough. So it will be a tool, a thing which will help in homebrewing rather than a finished product, which is like like an operator product, right? Like a plug and play product. I won't be buying those, I think, hopefully. Yeah.
Great. Dhiru, I think we've covered a lot of it. There are a few questions which people are asking on the YouTube channel. So maybe a quick reference to that, or if you could just briefly answer those questions. The first one is about making PCB. A lot of people have got a little bit issue on uh, how much prior knowledge you need to have of electronic theory. So making PCBs, A, how difficult it is, and B, instead of PCBs, can we use some breadboards?
Yeah, why not, right? Breadboard works to a certain extent. If you are doing audio work or low frequency, like I mean, when I talk to audio people, they say their work is critical and the breadboards don't work, right? If you talk to, let's say, a simple, I mean, it's like people think that their hobby is like different and it doesn't work on breadboards, but that's not the case, right? It can be made to work on, especially on zero board, zero PCBs, where you have those holes on the perforated PCBs, whatever you call them, right? It can be made
Zero
to
board.
work. Yeah, Vero board, yeah. So it can be made to work on that. Breadboard works to up to a certain extent. Of course, you won't be doing high quality fidelity audio stuff on it, but you can do basic proof of concept testing, right? Like, are my circuit connections right? Even before you approach that, you can do LT spice simulation. Is my idea right? Right? It will test for your connections and your idea. Does the idea hold up in journal, right? That can be done using LT spice at almost no expense. The expense is time and energy. PCBs, again, it takes learning. It's a learning curve, I think, and KiCad is makes things easier. There is this KiCad had a reputation, or at least in my mind, like it was hard and whatnot, right? And I was always trying to find ways not to make PCBs, but then I finally sat down and Sean Heimel has a very good YouTube like video. Sean Heimel like he often works with DigiKey, and they have a video series on YouTube on how to use KiCad. Of course, there might be more modern resources out there, so you could use those resources. It takes 2 or 3 days, right? Just to like keep like adapt to it, right? And to see where the things are in the KiCad UI. Let's say you want to add a register, how to add a register. You want to add an MCU, how to add an MCU, how to do the connections wiring. Then how this is the schematic part. Then you do a PCB layout. So it's not hard. And so if you look here, right, like look at this. It's not very like look at this. Uh, it takes a while for things to evolve. I mean, this is also wrong. The other one was also wrong, but this is less wrong, right? In many ways. So it's a art, I think, and you learn over time. I am still learning, so don't be scared and just jump right in. I think, yeah, that's the answer.
So there's a related question, Dhiru. If somebody doesn't know KiCad and they are learning, but in the meantime they want to get a circuit, they have a circuit, but they want to get a PCB done. Are there any service providers who will create a PCB for you with the circuit diagram rather than the sketch being shared with them?
Right. Even let's say you have an idea, there are many turnkey EMS providers out there, right? I can share some of the references, but yesterday also I got a call from someone like I told them I don't need your PCB services or your design services. I just need my server like product to be manufactured. They were like, no, we help with the idea. You have an idea and we'll do everything for you. So there are a lot of these people out there that they are known as, I believe, turnkey EMS services, right? Where you describe your problem to them and they will solve it for you, of course, for a price. And that price is like not too much, many times. I think like I got a quote for like some of the stuff and it was reasonable, I think. So we
Okay.
can dig into that and we can provide some references and all of that. Yeah, for sure.
One very radio related question. You completed your DXSE, so we spoke a lot about all the home brewing and electronics and the RF part about it. But you also completed your DXSE. How was that experience, Dhiru?
It was very like the first DXCC in on 20 meters, because I read some articles like you have to be on 20 meters the DX band. I Because it's easy. I completed 95 countries or something like that. Then I got hospitalized due to Corona, right? And then in the hospital, I was wondering, ये तो अब नहीं होगा. Means it won't happen. अब तो ये लगता है मतलब मुश्किल लग रहा है. It means it's hard now. It could be hard now. But then I got back again after some months. I got the enthusiasm back again and the motivation back again to do hobbies again, right? So it was quite an experience. And once you complete it, it's excitement as well, but it's also a relief, right? That I don't have to deal with this anymore. Like, I mean, like it's
True.
done. It's done. I mean,
Understood.
some people enjoy the operation side of it, the operating part of it, collecting rewards, the certificates, trophies, whatnot, right? And some people just, I guess, are in the like indifferent or not so attached to it, I think. Yeah.
Perfect. I think thanks, Dhiru. That was a great conversation, and you provided a lot of reference material. So we'll try to put some of those references in the show notes. Also, I'm sure we'll need to go through this multiple times. You have been a treasure trove of information, is what I'd say. You've really supported or you have helped a lot of people in understanding or overcoming some of these challenges or fears, is what my takeaway is from this conversation. Thank you so much for your time. Thanks a lot and have a great day. Thank you so much.
Yeah.
I'll say 7-3.
Yes. 73 is to you, Ajay and Devin. Thanks for having me. Thank you. Yeah. All righty.
Bye
All the
bye.
best
Thank
for
you
the
very
day ahead.
much.
Bye.
Bye bye.